The last couple sections we have been talking about lines of best fit, which are called a regression line for our scatter plot. Now, when we create this regression line or line of best fit, this is a sample statistic because it's based on calculations from a sample. So, maybe we have a sample of high school students and GPA and their ACT score. Okay, and so we're trying to see, like, is GPA a predictor of your ACT score? But we don't have the entire population. Okay, so a true regression line would come from a census of the entire population. So if you got like every student's GPA and ACT score, you could create the actual regression line. So the actual regression line is y equals beta 0 plus beta 1x. Okay, those are population parameters. So their true regression line is represented with Greek letters. We never actually calculate this because we don't have a census. What we do is we use our sample, so maybe we use 100 students or whatever, and we create a line of best fit for our scatter plot, and it is y hat equals b0 plus b1x. Okay, so this is your y-intercept, b0 is your y-intercept, b1 is your slope. In 12.4, we'll go on and we'll have more variables here, so that's why it's b1, because next lesson we'll get b2 and b3, so it'll expand out. Now, y is the actual value occurring within a population, okay? So that is sometimes a verb, sometimes it's not. And then y hat is the predicted value. Okay, so when we're using our regression equation, we are finding the y hat, the predicted value. Those are not often the same. So the difference is called a residual. The way we find residuals is always y minus y hat, the actual minus the predicted. Okay, I might even type that here. So that is actual minus predicted. Okay. I want to show you this on Desmos. Desmos does a really good job. Your calculator can do it all too. It just takes a little bit more work. So we're going to look at the table on page 839 in your book. It has data for children's ages and their reading levels. Okay, so first we're going to do this on Desmos and find all of these things. It's actually number 2, to find the residuals. So let me pull Desmos over here. So in Desmos, remember to create that scatter plot, you go to that plus sign and you insert a table. I already did that just to save us a little time. So you can see our scatter plot here, and it is very linear, which makes sense. As a student gets older, their reading level generally goes up. And we want to create a line of best fit. So remember, to do that, we use y equals mx plus b, but we want x1 and y1. So y1, and then instead of equals, we use that little tilde, approximately, mx1 plus b. And it'll create our line. Now, we didn't run a test on this, but you can see our R value is 0.9889. That's very high, so this is very strong linear correlation for that. And it gives us our parameters. It tells us what our slope and our y-intercept are right here. Okay. Now, the other thing that Desmos does is it does the residuals well. For example, let's look at an 8-year-old, okay? If we were looking at an 8-year-old, their predicted reading level would be right here on the line, and I have that here. It is 3.01. Maybe it'll show up, okay? That one. The actual, there it is, okay. The actual one we observed from our data was 3.7. Okay, so what our equation gave us, it was only 3.1, when actually that 8-year-old student had a reading level of 3.7. So let's look at another one. Let's say a 13-year-old. 13-year-old would be over here. We would predict that the 13-year-old would have a reading level of 7.4. From our data, this 13-year-old only had a 7.1. Okay, so what the residual does is it tells us the difference between these. Okay, do you see that our actual is above the predicted, or our actual might be below the predicted? So if you go back over here in Desmos to where it says residuals, residuals are also called errors, it'll plot those for us. okay? And it'll calculate them for us. So here, that 8-year-old that we were talking about, that we were expecting the 3.7, this error means that the distance between these 2 points is about 0.6, and then it plots it right there, okay? This one, our actual value is below what we would predict, so that residual is below. So these dots, for each one of these, it tells us how far above or below the line it is. Okay, so this one you can see is quite a bit below the line, so that residual is a negative. This one up here is quite a bit above the line, so that one's positive. And then you have one like this that's practically on the line, so this residual is practically 0. What you want to see from your residuals is you want them to be pretty close to this x-axis, okay? Now, your graphing calculator will do all of this. So let me walk you through all of those steps, okay? So find a graphing calculator and we'll get started here.